Hello, welcome along to the Fun Kids Science Weekly. My name's Dan. Thanks so much for listening. This is it. This is the only show that promises to uncover all of the secrets that are lurking out there in the universe. This week we're talking about what happens when a noise gets so loud it can kill you. Honestly, that's this week's Dangerous Dan. It's pretty serious stuff. We'll also talk about how lockdown has changed the way wildlife behaves, and you can find out why places in the Arctic Circle are getting worryingly hot. I'll answer some of your questions as well. This week they're all about senses, about animals moving to the earth from the sea, and about soil and vegetables. That's on the way. First, let's get into it with one of our favourite geniuses on the show. This is Professor Hallux.
Professor Hallux's Digital Dental Depository, with support from Philips Sonicare.
To honour great Uncle Halitosis, dentist extraordinaire, on the occasion of his 100th birthday, Professor Hallux is creating a pop-up digital dental depository, an oral health help desk. He's going to see how many questions all about teeth he can answer against the clock.
We're getting to the root of the matter today, Nanobot. All the questions are about teeth.
That's a pearly idea. OK, here goes. What are teeth?
Great question. Well, obviously the prime purpose of teeth is to help us eat food. They also, though, help us smile and talk. Teeth might look smooth and white, but there's a lot going on under the surface. The outer coating, the part you can see, is called the crown, and it's coated in tough enamel which acts like a shield. Well, it has to be when you'll be chomping through as many as 100,000 meals over your lifetime. The next layer is dentin. This is a softer material than enamel and acts as the last line of defence for the squidgy pulp where the nerve endings and blood supply run. It's these sensitive parts that cause toothache when a tooth has been injured. And then there's the root that anchors the tooth to the jaw. As the root is not protected by enamel, if it gets infected, it needs immediate attention by a dentist.
Cracking start, Hallux. Next question coming. Why do teeth look different to each other?
Well, that's an easy one. It's because they do different jobs. The teeth at the front of your mouth have a sharp edge. They're called incisors, and their job is to slice and cut. Great for biting into apples. Your canine teeth sit next to your incisors. They have got a point to them, literally. The pointed tip is to help tear tough foods like meat. Towards the back of your mouth, you'll find your premolars and molars. These are flatter, bumpy teeth which help grind up lumpy food like grains and seeds. And then hidden at the back, often under the gum, are your wisdom teeth. These are large and have a similar role to the molars. They're left over from prehistoric times when our diet would have included a lot more rough stuff.
Another great answer. Right, next question. What are baby teeth and why do they fall out?
A baby's head and jaw is very small. There isn't enough room for adult teeth. Baby or milk teeth are temporary teeth which appear when babies are around 6 months old. You have 20 baby teeth, 10 on each jaw. They stay with you until you're around 6 or 7 when they start to fall out, to be replaced by 32 adult teeth, which have been quietly growing under the surface. All your adult teeth should be in place by the time you're 14, except for your wisdom teeth, which may appear any time from late teenage or not at all. And if you're lucky, the tooth fairy will give you some pennies. Just don't forget to put the tooth under your pillow at night.
That's correct. And time's up. Brilliant, Professor. Very respectable score there and lots of data for our digital dental depository.
Professor Hallux's Digital Dental Depository, with support from Philips Sonicare. Find out more at funkidslive.com/Hallux.
It's time for my favourite part of the show. I know I say it every week, but it seriously is. It's when you turn me into a science Sherlock. You ask me your questions over on the Apple Podcast Store as a review for the Fun Kids Science Weekly. A science question that's just rattling around your brain. I figure it all out. I do all the work, all the research for you. This is from Jaden, who is in Jersey, who asks, how do you lose a sense? It's a tough one to answer to start us off, Jaden. You see, there are many reasons why you lose a sense. And normally it's because the part of the body that you need for the sense becomes damaged. To answer this, I think we'll focus on eyes, one of the 5 senses. People go blind when a part of their eye becomes damaged and can't work anymore, or there's something's wrong in the communication between your eyes and the part of the brain that makes sense of what you're seeing. Perhaps the lens that lets in light becomes blurred because of illness, or the eye's shape changes as you get older and your skull grows. Now, the optic nerve that takes the image to the brain can become damaged in an accident or through illness. Hearing a really loud noise as well can also damage the cells in your ear, which can cause you to be deaf. It's such a hard one to properly answer, Jaden. There are so many reasons why you can lose a sense. Usually it's about damage, but we will talk about loud noises, really loud noises, in a little bit. It's in this week's Dangerous Dan. Also, hello to Poodle Face Snake. Great name. They ask the question, how did animals get to Earth if it was only sea creatures first? The most common thought there is through evolution. Evolution is the survival of the fittest, right? Species are always looking for ways to grow and survive, and it's done randomly. There's usually not a conscious thought about how a creature can survive. They'll kind of mutate, and then that'll really help them out. So think of the sea, right? Think of the sea with all of those creatures that are in it. They're all battling for food. One day, probably a fish was born randomly that could move and breathe on land. Maybe it could wriggle through the sand, or it had legs. It was a mutant. It was different from all the other of his species. But that really helped it out, because then the animal got onto land where there's so much more food for it to survive. Then it has babies, and it makes a newer kind of species that can survive on land. Scientists think that it's through this random chance, these random mutations, that help evolution happen, which would have made one sea creature be able to live on land. It's a massive subject there, Poodle Face Snake, but thanks for the question. Lastly, thank you to Innes from Scotland, who asks, what is in soil that makes vegetables grow? Soil has 3 main functions in the garden: to anchor plants and give them a place to grow, to give them water, and to provide them with minerals. Now, there are 3 major elements in the soil that plants need to grow. There is nitrogen, which is in the soil, and it's found in all plant cells. This is vital. There's also phosphorus, which puts energy from the sunlight back into the plants. And it also helps the roots grow early on. It helps them take root. And also there's potassium, which helps plants become resistant to diseases, and it helps move some important starches all around the plant. So in this, that's what makes veg grow in the soil: potassium, phosphorus, and nitrogen. Thank you so much for those questions. If you've got something sciencey that you want answered on the show, you need to leave it for me as a review over on Apple Podcasts. It's the Fun Kids Science Weekly. Now, NASA have come up with a way that you can help rovers explore Mars. What a first line to an interview. To tell us more, we've got an actual NASA Rover Driver on the line. Sophia Mitchell, thank you so much for joining us.
Yes, of course. Thank you for having me.
Now, I'll be honest, I know quite a bit about science. I had no clue until recently that NASA Rover Drivers existed. Tell us more about what you do.
It's definitely one of those unique jobs that you don't think a lot about, but obviously somebody definitely has to drive the rovers around and tell the robotic arm what to do. And so that's what I do. I work with a team of people, and we get the data down from the rover several times a day. And then we'll take that data, figure out where the rover is, what we'd like to do with it based on the science team, their input. And then we tell the rover where to go. And sometimes I jokingly call it Martian Uber, because it's really the science team leading us to where they think we can find interesting rocks to drill or interesting features they might want to study. And then our job is to safely get them there.
So how does it work as being a rover driver? Are you driving it as you would drive a remote control car, or is it doing all of the movement itself? You're just telling it where it needs to move to?
So it's doing all the movement itself. There's a 7-minute delay for a signal to get from the Earth to Mars, and then that same delay on the way back. And sometimes, depending on where the orbits of the different planets are and how the Earth and Mars are rotated, we might need to relay our data off of a satellite orbiting Mars. So you can imagine we can't always directly talk to the rover, but what we tend to do is, instead of using a joystick style thing and driving that way, we plan entire days at a time, sometimes up to 3 days at a time for a weekend plan. So it's more a model-based we kind of use coding, and we like computer programming and models based on where we know we are on the surface, and use that to kind of write a code that tells the rover where to go.
Now, Mars as a planet, though, is, it's not as built up as it is down here on Earth. It's not like there are cities and people walking around. And I mean, you've not been there. No one's been there. How do you know where to send your rover? What are you looking at? What are you looking for? Where do you think you're going to look for it? How are you getting this inkling that maybe the rover needs to go here today?
So we get images from the satellite called Mars Highrise, and that gives us, Mars Reconnaissance Observatory. It gives us Highrise data. And that data is basically an orbital mesh of what the surrounding area around the rover looks like. And then as we come upon these different places, so we can see where ridges are and things like that generally, as we get closer, then we take pictures with the rover using our mass camera and our navigation cameras. And what's cool about those pictures is that each pixel has range data with it, meaning that the rover knows how far away the ground is in each pixel. So we can use that information to build a three-dimensional map of the terrain around the rover. And then as we're planning on where the rover should go, I like to think of it like hiking. I try to think of, if I were walking around on the surface and the terrain looked like this, where would I want to walk? And so that's kind of how we guide ourselves in determining where to put the rover.
Quite a boring day job question, but how do you know what you're going to do every day? Do you just get to work and, most people get to work and then they're told by their boss, hey, here's what you're in for today. How does it work for a Mars rover? What does your day at work look like?
So it depends a lot on what the science team wants to do. They use that data that I was just talking about to also see where interesting rock outcrops look, or where they may be, or maybe we're coming up on a section of the surface that has more hematite, more iron in the soil, and so they want to make sure we go over there. So a lot of what we end up doing during the day depends on the science team's goals and what they decide would be the best use of our time and resources.
And it sounds so simple, but what are you looking for when you are roving around Mars?
So in the end, we're looking for signs of past life on Mars, because basically, as we drive up right now, we are on what's called Mount Sharp. It's this mountain that we've been climbing. We landed in 2012. It's been almost 8 years. One thing about climbing up this mountain is as we go higher, then we're basically looking at a geological history of Mars, because with each layer that we go past, that's a different time period in Martian history. And so by studying the rocks and all these different layers, we can see what Mars may have been up to in the past. If there was ever any sort of bacteria, we know that there was water. We know that there's still some subsurface water. So, we're just answering some of the questions about how life exists in our universe, and also how our solar system formed and how maybe the Earth's history might have looked. So,
you say there was water, Sophia. Where has it gone? The majority of Mars is water. Where has it gone to?
So Mars is a lot smaller than Earth, which means its atmosphere is very thin. And so water can escape that way. And it also, it doesn't have a rotating inner core. So that means it doesn't have a magnetosphere. So on the Earth, the reason why we have the auroras is because that's our magnetosphere pushing the solar wind kind of around the planet. And so that ends up protecting the Earth's atmosphere a bit from that. Since Mars doesn't have that, then the atmosphere is kind of blown off. And so between that and the lower gravity, it's a bit easier for water to evaporate out into space, for example. Mars also has polar ice caps, and so some of the water may be there. It's quite a bit colder than Earth. So it may just be frozen below the surface, and some of it may have blown away.
Again, very simply, how do you get to be a Mars rover, a NASA Mars Rover Driver? What's been the path that's led you there?
So my schooling is in aerospace engineering and controls. And so I went to University of Cincinnati in Ohio in the United States and got my bachelor's and master's degree in engineering. And then at JPL, which is where I was hired after graduating, I was actually working on making simulants, rock simulants, for a different mission completely, and ended up gaining a lot of insight into how robotic mechanisms interact with rocks. And so going back in time to 2016, Curiosity actually has a broken drill. The drill can still rotate, but it can't feed forward. And so why that's important is because the way that we drill on Mars is by preloading it against a rock and then feeding the drill forward. So you can imagine if you've ever tried to drill into a wall in your home, then you're trying to hold the drill straight, your elbow pops all over the place. It's not, you can't, quite keep it straight, things like that. It's very difficult. And so that became the way that we had to learn how to drill on Mars, is with nothing stabilizing us. So trying to keep the arms stable and make sure we're drilling straight. And so because of my experience with robotic mechanisms interacting with rocks, I got pulled onto the Curiosity rover team that way and trying to help them solve the drill problem. So, and then as I got more experience there, at one point, it was just offered to me to join the training team to be a rover driver. And of course I said, sure. So that training program is a couple years long. It takes a long time because you have to learn how the entire robot works, how it's going to respond to different situations, and just get a feel for what motions will work best on different types of terrains, so we don't slide too much, or so it's not too risky to put the wheels over something sharp, things like that. So there's a lot of training involved, but yeah, it was kind of a roundabout way to end up being a rover driver. And we all have different stories. There's not really a specific route to going from school to rover driver.
Now, I've been doing this podcast now for probably about 3 years, I think, and I've chatted to so many people, and I have to say yours is just the most exciting job anyone's ever had. But what's the most boring part of it, Sophia?
Oh my goodness, the most boring part. There's some paperwork. If something goes wrong and we have to write all of the issues down, it's of course very helpful to record everything and to be able to do technical writing very well, but it's not my favorite part.
Now, what I think one of the hardest parts of your job must be when the rover is getting damaged, where it's going somewhere it's not really meant to be going, and there's a way that we can help you out with that, isn't there? It's called AI for Mars. It's a tool which needs us to draw on pictures of Mars. Can you tell us a bit more about it?
Yeah, so AI for Mars is this really awesome effort. So basically the idea is that people from home, and especially now that we're all stuck at home, can help us identify terrain types and obstacles on the surface using the images that we take with the Curiosity rover. And so you're kind of doing a bit of what the rover drivers do now when we come in first thing in the morning. When we get our data down from where the rover is, then we pull the pictures up and say, oh, that's sand, there's a rock, that's some bedrock, that's gravel. So by helping us identify those things in AI for Mars, you're actually doing a little bit of rover driving yourself. But what that helps us with is we always want to make things as autonomous as possible. It's just more efficient to do that, especially with a rover that's on a different planet. So we can get more science done if the rover can drive itself more often. So that's all of this data that people are making when they look at these pictures and they classify terrain. They're basically making a huge data set that we can use to train this algorithm that we have that will then look at these pictures as they come in, and based on how people have classified similar looking terrain, say, oh, I'm pretty sure that's sand, or I'm pretty sure that that's gravel. And then we can more quickly decide where to drive, and eventually the rover can decide on its own where to drive.
Oh, it's just the best idea ever. It's called AI for Mars, the number 4. If you just give it like a quick Google online, you'll be able to find out all the details you need very, very quickly. Sophia, listen, it's been an absolute treat. Thank you so much for joining us.
Of course. And again, thanks for having me.
Now, this week's Dangerous Dan is about when a noise gets so loud, it can kill you. This is really serious, kind of gory as well, but go with it because it's so fascinating. You see, when you hear loud noises, it affects your stereocilia, which are little groups of hairs in your ears that detect vibrations and translate that into messages that your brain understands. Now, when they get damaged, they send messages to your brain that there is still noise happening when there isn't, which is why you get ringing ears, maybe if you've been to quite a loud show. But noise can do a lot worse than just keep your ears ringing. Scientists measure the amount of noise in decibels. Now, a lawnmower makes a sound at about 90 decibels. A baby crying can get to 130. An airplane's engine gets to 140. Over 150 decibels can do you serious damage. But when you get over 185 decibels, it gets really serious. At that point, just a sound can kill you. Your eardrums get destroyed by the noise. The vibrations of the sound travel right into your head. It ruptures your eyeballs and your lungs. It can kill you from the inside out. There's also something called blast overpressure, where huge noises release a massive amount of energy. It forces your lungs to fill with so much air, because of the change in air pressure, they burst. Now, space agencies around the world, they test things that go into space by playing them a really loud noise to see if they could survive a rocket ship launch. The European Space Agency are so worried about the damage that this huge noise can do to humans, they've covered their test room in a wall that's over 1 meter thick. Anything over 185 decibels can do you serious damage, could perhaps be fatal. Just a noise. Who'd have thought a loud sound could finish you off? We're travelling right through space now with another episode from our new series, Thunderbirds Are Go Mission to Mars. This is where Ko and Brains from Tracy Island, some of the actual world-famous Thunderbirds, are here to take us to the Red Planet.
5, 4, 3, 2, 1.
Thunderbirds Are Go Mission to Mars.
I'm here on Tracy Island finding out about the ExoMars mission with Ko and Brains from International Rescue. I still can't quite believe that I'm here.
I can pinch you if you're not sure.
Thanks, but I think I'll pass on that, Brains. I'm hoping you can tell me about what I reckon is the most exciting part of the mission, looking for life. That's the main mission objective, right?
That's right, Dan. We're talking about life that might have existed on the Red Planet billions of years ago.
So what are the signs of life that ExoMars will be looking for? Are we talking little green men or dinosaur fossils?
We're fairly sure there aren't any little green men on Mars. And ExoMars isn't expecting to find anything as big as a dinosaur. It's looking for biomarkers, signs of the life which may have existed in Mars's past.
And like life itself, biomarkers come in all shapes and sizes. Some are patterns in the terrain of the planet, others could be gas or a particular mineral.
The biomarkers that Rosalind will be seeking are molecules with the right structure and the sort of shape and size that we know is found in living things. Let's check out the tech. This is the Mars Organic Molecule Analyzer, or MOMA for short. It's one of the instruments on board the rover. It's a lab full of chemistry equipment, although as you can see, it's the size of a toaster.
So, it's a laboratory. Looks a bit too small to have little green men in white coats inside, running around and doing experiments.
Very funny, Dan. Instruments and robots can help us to analyse data and run experiments. Max is just as much part of the International Rescue Team as any human.
So here's how it works. As we know, Rosalind the rover will collect tiny samples of rock from underneath the surface of Mars. MOMA will heat those samples to extremely high temperatures, creating tiny particles called evolved volatiles. These are sent through a gas chromatograph. And MOMA will ionize and analyze the gases that come from the sample using an electron ionization mass spectrometry. Simple.
Simple?
Brains just means the molecules in the samples will be sorted into types.
That's what I said. There's also some cool technology that will help keep the bonds in larger molecules together, so we can get a really accurate picture of what's there.
But what kind of molecules will they be looking for?
Well, elements needed for life include carbon, nitrogen, oxygen, and a bunch of others. But it's not just what molecules we find, their shape is important too.
What? Like diamond-shaped? Oblong?
All sorts of shapes. Each type of molecule can come in two opposite versions, like being left-handed or right-handed. In general, you'd expect to see a mix of both, but living things tend to have more of one kind so they can fit easily with others to create organic matter.
So if they see lots of one type, that'll be another biomarker.
That's right. Top marks.
Or should that be top biomarks?
Thunderbirds are go, mission to Mars, with support from the UK Space Agency and International Rescue. Find out more at funkidslive.com/space.
Right, let's get this week's Science in the News. Scientists have started to track wildlife before, during and after the lockdown to see how the slowdown in humans doing stuff has affected other species. They say that measuring this will reveal ways that we can share our increasingly overcrowded planet. They're seeing whether animals are travelling to places that are better for their species while there isn't any humans there, and maybe this can carry on as we start to leave our homes more. Also, temperatures in the Arctic Circle are thought to have hit an all-time record, hitting a scorching 100 degrees Fahrenheit in Verkhoyansk in Russia. You know the Arctic Circle, you think ice and snow, don't you? Not boiling hot sunshine. Sometimes it makes it down to minus 42 degrees C in January, but this persistent heat wave has worried scientists and reinforced the need to keep thinking about the climate crisis. And finally, China has put the final satellite in its Beidou 3 system into space, meaning the country is now a major power in space travel. The £8 billion network is made of 35 satellites and will provide more global navigation coverage. And that is it for the Fun Kids Science Weekly. Thank you so much for listening. If you want to hear any of the series that you've heard today and loads more, you can do that through Apple Podcasts. Find us there. You can also get us wherever you normally listen to your shows, and they're at funkidslive.com too. Now, if you've got a science question that you want answered on this show, you need to leave it for me as a review over on Apple Podcasts. Search for the Fun Kids Science Weekly, leave me your name, drop 5 stars, it'll really help me see it. There's a little comment box at the bottom, that is where you leave your question. I really will do my best to answer it. And Fun Kids, we're a children's radio station from the UK. You can hear us all around the country on your DAB digital radio, on that free Fun Kids app, and as always at funkidslive.com/.